Hey everybody, welcome back to Mathematical Misconceptions. Today, we're going to talk about a common mistake I see when people try to break up logarithms. They assume that we have log of a plus b all on the inside, and then they say that it's equal to log of a plus log of b. But that's not the rule. And there are a couple things that you have to consider as well when you're doing this. Number one, you should plug in a number or two to make sure what you're doing is actually factual. And secondly, there is no way to simplify this any further that we know of at this time. There's a different way to write this that is correct, that is an identity. And again, we're always looking for identities because that's how we transform algebraic expressions. As a reminder, what does the logarithm try to answer? It answers if we have log base of b of n, a number, is equal to p, which we'll call a power, we can always rewrite it as the base to some power gives you that number. So the question that we always answer is, what power do I need to raise the base? What power do I need to raise the base to achieve the number inside this number, n? That's the question that we have to answer every time. And if b is not given to you, you have to assume it's 10 by default, unless there are instructions that otherwise say assume 2, which is the other common one if you don't use natural log, ln. So what power do I need to raise the base b to get the number inside? And that's what logarithms look to answer. This is an exercise for Algebra 2 students and above, so if you're not there, earmark it and come back to it. Otherwise, I hope you're ready. Let's dive in. Of course, what do I always do with these things? I always plug in numbers, right? And remember, the log is not specified for the base, so we assume it's 10 by default. So we want to choose easy numbers for log base 10. And it's basically a 1 with any number of zeros. That's pretty easy to work with. Let's choose a to be 1,000. Let's choose b to be 10,000. All right, let's go ahead and plug these things in. So we have log of 1,000 plus 10,000 is not going to equal log of 1,000 plus log of 10,000. Alrighty, so let's just focus on the right-hand side first. So these ones are pretty easy. So log of 1,000 answers the question, what power do I need to raise the base? And the base is 10 to get 1,000. 10 to what power is 1,000? It's 3. 3 plus, and then same thing with 10,000. What power do I need to raise 10 to get 10,000? 4. 10 to the 4th power is 10,000. And that's the beauty of log base 10, is that when you're working with clean numbers, you just really have to count the number of zeros. 3 zeros on this one, right there. 4 zeros on this one, right there. It's easy to do. Now, what about if I plug it into here? We need to add the two numbers out. So 10,000 plus 1,000 is going to be 11,000. And this is not going to be equal to 3 plus 4. Whenever you're evaluating something like this that doesn't have a clean answer, use a calculator. So I'm going to use my HP prime, and I'm going to look to answer the question. Something tells me it's going to be somewhere between 3 and 4. So let's do log 11,000. And that's going to give me an answer. Oh, it's actually bigger than that. It's going to be 4.04, which is not equal to 3 plus 4, which is 7. So that's how you can prove to yourself that this is not an identity, is that if you were to plug in some numbers and use easy numbers if you can, and if you have a calculator, you can basically use any numbers that you want as long as that you obey the domain of log, which is it's all real numbers greater than 0, not including 0. Then you should be able to figure this out. But if you just want easy numbers to contend with, I always say just use numbers that you know are, you can exponentiate easily and achieve 1,000, 10,000, et cetera, et cetera. But clearly we see that 4.04 is not the same as 7. So that's how we have disproven this proposed identity. It is not an identity. There may be a condition or two where it does work, but again, we're always looking for identities, not exceptions. All right. Now from here, it begs the question, what is the law that we have to work with logarithms? Well, it's not a plus sign in the middle of the parentheses. It is actually multiplication. I have a name for this. You can feel free to adopt it. It's called the product to sum law. And the product to sum law basically states that if you have the product of two numbers inside a logarithm, you can write them as the sum of the individuals. So log of a times b is equal to, and now we can lift this, or maybe we can't. Maybe this is wrong too. Let's assume we can. Log of a plus log of b. Let's use those same numbers one more time. This time I don't think I'll need a calculator. I'm going to use a to be 1,000 and b to be 10,000. All right, so now we have log of 1,000 times 10,000 is equal to, we'll just write it out one more time, log of 1,000 plus log of 10,000. Now I'm going to show you a couple ways to verify this. And the more ways that you learn to look at logarithms, the more flexible and adaptable you'll be when you're doing any algebra. So in this case, if I take 1,000 times 10,000, there are a couple ways that you can do this. The first way I could say is just brute force it. This is going to be log of 10 million is equal to, what's log of 100? Well, log of 100, 2. How about what's log of 1,000? That's 3. And then log of 10,000, 4. Now, we answer the question again. What power do I need to raise the base, 10, because it's not notated, to achieve the number inside? 10 to what power is going to give me 10 million? 7. 7 equals 3 plus 4. Check. And that's how you more or less can verify things are identities. Now, if you're doing homework, you should try different numbers, try to play around with things, and make sure that the left-hand side is always equal to the right-hand side. On a test, you want to choose easy numbers that allow you to verify whether this is an identity or not if you are not so sure. Do the work up front, you won't have to do that on a test. All right, what's another way we can verify this? What's another nice way to do it? Well, the way that I like to do it is I like to actually write things in exponential form. So we have log of, and then 1,000 is 10 to the 3 times 10,000, which is 10 to the 4. And what's 10 to the 3 times 10 to the 4? Like bases, multiply them together, add the powers. 3 plus 4 is 7. So it's going to be 10 to the 7th power. So again, this is 10 to the 3 up here times 10 to the 4. 10 to the 3 times 10 to the 4 is 10 to the 7. So far, so good. Equals, write this in 10 to some power as well, 10 to the 3 plus log of 10 to the 4. And then what is the rule for exponents? When we have an exponent on a number, we can use what I like to call the exponent to coefficient law. So the exponent to coefficient law basically says that you can take these exponents and they become coefficients in front of the logs, like this, this, and like that. So we have 7 log base 10 of 10 is equal to 3 log base 10 of 10 plus 4 log base 10 of 10. And now you could just take log base 10 of 10, log base number of any number itself is 1, right? So we can just basically just scratch all this. You can also add these two. These are like terms. 3 plus 4 is 7. You could also verify it that way. So you have 7 equals 3 plus 4. And that checks out. Alrighty, so be careful when you're doing logarithms. You don't want to invent rules that don't work. And we explored the product to sum law, but I also want you to explore the quotient to difference law, which also follows a very similar pattern, that just because you have a minus sign inside the parentheses doesn't mean you can write it as a split. Now with numbers, it naturally does make sense, but when you have algebraic expressions in here, you do have to be careful and make sure that everything that you do is true for all real numbers, or at least the numbers that are in the domain of log. For all numbers greater than 0, 0 is excluded. So be careful about that. All right, guys, that was mathematical misconceptions with taking the log of a plus b and rewriting it like this. You can't do that. It has to be the product. And then, of course, when you have the quotient, you're going to have the difference rule. If you have any questions on logarithms or anything else in algebra, please drop a comment below, and I would love to address it with you. Otherwise, I'll see you in the next video. Thank you.